Hi everybody. I hope yesterday you went through the lecture material and by now you have a bit of an understanding where we're going. So this video is just like highlighting some of the important points in the lecture 1 for observations. And yeah, I just wanted to make sure that you guys are on the same page with me. And so we're talking about global observations and how it's important. So if you go through the first couple of slides, you will see how it's very important why we need to monitor our oceans. And this is the second slide. I like this a lot because it shows how we've really done a lot of progress in terms of monitoring the state of our oceans. So if you look at these are auger floats. We'll go through this in the next coming lectures. Auger floats sitting all around the ocean, and it's like it looks very populated, but trust me, it's still very little data that we have. I mean, we could do better, but yeah, we have all these auger floats monitoring the ocean and helping us bring in more information, feeding, yeah. So first of all, some important terms that you guys will need to familiarize yourself. We've got Lagrangian. It basically means measurement following the flow. And eulerian, it is a measurement at a fixed location. So one is following, one is fixed. Time series, so if you guys have done stats, you're looking at over a time span, and at a fixed point, you measure a particular property, but comparing it with time. And then a snapshot is, for instance, we look at yesterday how many infected people were infected with coronavirus, since we are during these days. But an important, maybe an easy way to understand Lagrangian and eulerian is you can look at it like we have two guys. One guy's name is Lagrangian and the other guy's name is eulerian. So what happens is Lagrangian and eulerian, they both have a massive crush on this girl. And Lagrangian is the neighbor and eulerian is the guy, the colleague at work. So what happens is Lagrangian, he's a stalker. He takes his bicycle, follows the girl everywhere where she goes, makes sure where she is at every time. And eulerian is sitting in his office watching over that girl from 9 to 5 every Monday to Friday, but that's about it. Once the girl leaves the office, the eulerian has no idea what's going on. So maybe that gives you a bit of a context how to distinguish between this. There's a question in this in the practical which you will need to answer. So we're going through some of the main methods how to collect in situ data. Now I won't be able to go through everything because I can't actually make long videos, but I will try go through some of them. What's a CTD? If you look at the first picture, this one, or basically all of it, this is what a CTD looks like. And what a CTD stands for, it's basically conductivity, temperature, and depth. So it's a good tool. It's quite expensive also. When you'll see now that all oceanography that we do is quite expensive. But what happens is we deploy it at a particular area in the water, and it follows like a column of water. So you measure the column of water. And it's got sensors, it's got all sorts of sensors to measure temperature, to measure the pressure, to measure the oxygen and everything. So we can get a good idea of what's going on through that column of water at that particular point, right? So it's a eulerian method. And let's go for one more. Let's look at ADCP. ADCP basically stands for Acoustic Doppler Current Profiler, and basically measures the velocity and direction of water. So it's normally anchored or shipboard. An XBT system. So if you look at the slides, you will see a picture with like a gun. You shoot it, and it's got a little piece of wire which has